Okay, so we are going to talk about these important terms that are used in wave. So you cannot talk about wave without knowing about these terms. So we're going to talk about cycle, we're going to talk about amplitude, we'll talk about period, we'll talk about frequency, we'll talk about wavelength, and then we'll talk about velocity. Okay, so whenever we talk about cycle, when we say cycle of a wave simply means a complete movement of the wave. Okay, so when we say cycle of a wave, it means the complete movement of the wave. Okay, so what does that mean? For you to have a complete movement of a wave, you need to do what? You need to have an up movement and a down movement. So one up movement and one down movement will give us one cycle. Okay, that is how we define the cycle of a wave. One up movement and one down movement. One up movement and one down movement. That is what a cycle is. But if you want to define it technically, you can say that cycle of a wave is the complete up and down movement of the what? Of the wave. Now, if you understand what I have just done, look at this. So imagine I have something like this. 1, 2, 3. Okay, so this is what I have. Now I want you to pause the video and tell me how many cycles you can see here. Okay, if you got the answer, just comment it in the comment section of this video. Now, but let us see what happens. So if I have this is one cycle, so meaning 1, this is 2, this is 3, this is 4, and then this is what? 5. So whenever you are counting the cycle of a wave, it is just up down is 1. So up down is 1, up down again 2, and just like that. Okay, so one more example. So let's say we have this. How many cycles do we have here? Okay, so what do you have? 1, 2, 3. Now, because this side is not complete, remember, for you to make it complete, it is up and down. So it is only up that is here. So this will be what now? Half. So this will be half. And because it is half, I can say 1, 2, 3 and a half. So 3.5 cycle, or I say 3.5 cycles. Okay, so that is what cycle is all about. Now let's talk about the next one, which is amplitude. So when we say amplitude, we define amplitude as the maximum displacement of the wave from its equilibrium position. Maximum displacement of the wave from its equilibrium position. So what does that mean? Okay, so let's say we have a wave. Remember, we have talked about what a cycle is. So if I have a wave going this way, amplitude means the distance between this peak position. This is the peak or maximum position of the wave. So, and this is the equilibrium position of the wave. So the distance between this amplitude, between this peak point, and this equilibrium position is called the amplitude, and it is represented by A. The same thing happens here. Okay, so we also have amplitude there. This is A, the distance between the equilibrium position and the peak position of the wave. Now mind you that this peak here is on the negative side, but generally the values of A here is also equal to the values of A here. Okay, so that is what amplitude is. Now next one we'll talk about is period. So what is period? Okay, what is period? When we say period of a wave simply means the time it takes for a wave to complete one cycle. Okay, remember what a cycle is. A cycle is one up and one down movement. So the time it takes that wave to do one cycle is what we call a period of the wave. So what does that mean? So imagine I have a wave going this way. Let me just stop here. And this is the time axis. This is the time axis. And this is the distance moved vertically axis. So imagine I have this as a wave. Now what happens? If I can measure the amount of time from here to here, remember that here to here is exactly one cycle. If I can measure the time the wave takes to move from this position to this position, that time is what we call what? Period. That is our period. So the time taken to move from here to here is period. And we usually represent it by capital letter T. So period is represented by capital letter T. And mathematically, we can say that period is equal to small t over n. Period is equal to small t over n. What does that mean? T here means total time. Total time. That is what T represents. And N means number of cycle. Number of cycles. Number of cycles. So if we know the total time taken for a wave to complete a given number of cycles, we can calculate the what? We can calculate the period of the wave using the mathematical relationship. Okay? So that is that. Now, next thing we talk about is frequency. So when we say frequency, what does frequency mean? So we normally say that frequency is the number of cycles completed in 1 second. Okay, so whenever you say frequency of anything means how frequent does it happen. You can use that, if I can use that. Okay, so frequency is the number of cycles completed in 1 second. So let's imagine we have a wave, and then on our graph axis, let's say we have 0.5 seconds here and we have 1 second here. Okay, so and then we have this. So you see that from the start of the wave to this point is exactly 1 second, according to what my graph is telling me. Then the frequency of this wave now will mean how many cycles did it complete before it gets to 1 second. That is what it means. So you see 1, 2, 3, 4, 5.5. So that means the frequency of the wave is going to be 5.5 hertz. So the unit of frequency is hertz, or you say per second. That is s power minus 1. Okay, that is frequency. Now mathematically, you should know that frequency is 1 over period. So in your exams, you can also define frequency as a reciprocal of period. So f is equal to 1 over capital letter T. 1 over capital letter T. That is your period of the wave. So f is equal to 1 over T. Now, since we know that T is, remember that T is equal to small t over n. If I get the reciprocal of this, that is the inverse of this, you will see that frequency is N over T. So you can also have this as your formula for calculating frequency. N is still number of cycles, small t is still the total time taken. Okay, so the next thing we talk about here is wavelength. So what is wavelength? What is wavelength? What is wavelength? So when we say wavelength, we say that wavelength is the distance between successive crests or troughs of a wave. Now, what does that mean? If I have a wave this way, now the up movements of the wave are called crests. So this is a crest, this is a crest, this is a trough, this is a trough. So trough, this is trough, this is crests. Okay, so up movements are called crests, down movements are called what? Troughs. Now, when we say wavelength, wavelength is the distance between successive crests or troughs. So I have already told you that this is a crest and this is a crest. The distance between both of them, because they are consecutive, the distance between both of them is what we call wavelength. And we usually represent wavelength by the Greek alphabet lambda. So lambda, okay? We represent it by the Greek alphabet called lambda. So this is what we use to represent wavelength. Or you can also say from here to here, which is from trough to trough, is also wavelength. Either way, you can also go by that. Then when you go advanced, you would also find out that wavelength is also the distance moved in one cycle. Okay? You should know that. You should know that. So the distance traveled by the wave in one cycle is also known as what? Wavelength. So if you don't want to define it as distance between successive crests or troughs, you can also define it as distance moved in one cycle by the wave. Okay? So that is that. Now the next thing we'll talk about here is the velocity. Of course, when you say velocity of anything, it means how fast that object or that stuff is moving. So the velocity of the wave simply means how fast is the wave traveling. And all you need to know here is the mathematical representation of velocity. So velocity of a wave is always given as f lambda. Okay, f times lambda. So velocity of the wave is given by this formula. V is the velocity. This is the velocity. F is the frequency. We've talked about that. And then this lambda is the wavelength. Wavelength. Okay, so V is equal to F lambda. Very important formula. And then again, you can also say that V is equal to lambda over T. Okay, because remember we said that F is 1 over T. So you can remove F and put 1 over T, and this formula is also true. So any of the formulas given to you, make sure to know the one to use depending on the parameters given in the what? Question.